All right, ladies and gentlemen, so today we're going to talk about Lewis structures. So originally we spoke about the Bohr model, and the Bohr model shows all of the electrons that an atom has. Okay, so the Bohr model we saw today in class, oxygen had a total of 8 electrons, 2 in the first shell and 6 in the second shell. Well, in a Lewis structure, the Lewis structure shows only the electrons in the outer shell or the valence shell. Okay, so let's just go ahead and document that. Only shows valence shell electrons. Okay, so the way a Lewis structure is done is very simple. Basically, it just shows the atomic symbol with the number of electrons represented. Now, when I initially show people how to do a Lewis structure, I like to put a box around it. So let's go ahead and start with nitrogen. Okay, nitrogen is in group 7, okay, which means it has 7 electrons in its outer shell. Now, although it can be a little bit deceiving, the way the structure is placed, it is as if you're putting a box around the letter. So although the Lewis structure does not have a box, let's go ahead and place a box so that you can see, let me make that a little bit neater, so that we can see how the electrons are placed. So I put a box around nitrogen and I place the electrons 1, 2, 3, 4, and nitrogen, is in group 5, so it has 5 electrons in the outer shell, not 7, I apologize. It has 7 total. Okay, so when you remove the box, this is what the Lewis structure looks like. Okay, so when we create the Lewis structure, I know many people wonder how to place the dots around the atom, okay, around the atomic symbol. When you're placing the dots around the atomic symbol, it is done many ways. I've seen, for example, I was looking at one for beryllium, okay, beryllium I have seen done many different ways. Okay, I've seen it done this way. I've seen it done this way. I have seen it done this way and this way. Now I cannot verify. I don't recall ever seeing it this way, but that is not to say that it's not there. The bottom line is, as long as you have the right number of electrons around the atomic symbol, your Lewis structure is okay. I personally don't like to crowd them. So for example, for nitrogen, I personally would not do something like this. It's not to say that the Lewis structure doesn't exist, but usually, the way I see it, there's going to be an electron for one to pair with. So I like to organize them, fill every orbital first, and then go around and start all over again. So if you're looking at something like, let's say, argon, argon is a noble gas. It has 8 electrons in its outer shell. So argon looks like that, okay? And something like, let's say, hydrogen or lithium or anything in the first group, you can have it this way, you can have it that way, or let's say sodium, also in the first group, you can put it over here. The only thing is, if you're looking at a periodic table of Lewis structures, whatever the Lewis structures are, they're going to look the same for every element in that group. For example, here, these are different ways that these could be represented, but if you're looking at the same periodic table, what you will see is they will all have electron placement in the same place. So if you look at a group number, for example, group 1, and as a reminder, the groups are the columns and the periods are the rows. If you look at group 1, every single element in group 1 has one electron in its outer shell, so its electron configuration will be like this, okay? Every atom or every element in group 8 has 8 electrons in its outer shell, so its electron configuration is going to be like this, okay? So whatever electron configuration is chosen, once that electron configuration is chosen, it tends to follow suit for the entire group. So if I were to, let's say, for example, if I was creating a table for nitrogen's group, so everything in group 5, the only thing that would change would be the symbol. So for example, nitrogen would look like this. Below nitrogen, we have phosphorus. Phosphorus would look like that. Arsenic would look like that. Okay, so on and so forth. Okay, tin, okay, bismuth, and element 115 that I can't see from here. It is, oh, fluorovium. I was looking at the wrong one. So, this is what it would look like on a periodic table. They would follow the exact same pattern, whichever pattern is chosen. So you don't have to worry too much about whether or not you're making beryllium look like this, or like this, or like this, or like this. As long as you are consistent in your methods of presenting your Lewis structures. And again, the Lewis structure is very, very helpful when you're looking at the potential for bonding with other elements. So tomorrow, when you come into class, and I know some of us have a celebration tomorrow, but between tomorrow and Tuesday, when you come into class, you'll be getting this paper. And this paper actually shows you the first 10, but it also goes over what chemical formulas would be once you start bonding Lewis structures together. Okay, so you can look at how many bonds would make. For example, hydrogen, okay, hydrogen will usually bond with one thing. Beryllium can make 2 bonds, okay. Boron can make 1 bond if you're looking at, well, in order to fill its outer shell, it can get rid of its 3 electrons and make 3 bonds. Okay, so we're going to be going through this tomorrow, step by step, right after we finish practicing Lewis structures. But take the time, look up some periodic tables of Lewis structures. You'll notice they're only for the 8A elements. Do not worry about transition metals. They're kind of advanced for us right now. If you have any questions, feel free to drop me a line, post a comment, and I'll be happy to go ahead and help you out. Have an awesome night, and I will see you tomorrow.